is one of a series of short videos illustrating how to do computational physics in a programming environment. In this video we'll be looking at the basics of using functions within MATLAB. In a previous video we showed how to use some of the inbuilt functions which are available within the MATLAB environment, and in the command window we can of course call some of those functions. For example, we can find what the sine of pi is by entering in sine and supplying the argument pi within the brackets, and we get an answer, as you can see, which is very close to 0, as it should be. Random numbers, as we saw in the previous video, can be obtained by supplying a suitable argument, and by pausing when we enter the rand function and we enter a single bracket, we will obtain the list of possible options which it is possible to supply. And many inbuilt functions have a number of different ways of being called. So if we supply the number 3, then we get a 3 by 3 matrix. If we supply no argument at all, we get a single value, and sometimes we can even omit the argument altogether, and we will also get a single value. So these inbuilt functions are predefined for us, but what if we want to define our own functions? Are we able to do that? Well, if we look under the New menu, we will see that as well as being able to define a script, we can also define a function. And when we write a function, it is usually best to do that by clicking on this button rather than defining a script and giving the word function at the beginning. As you can see, when we clicked on that button to define a new function, a so-called template has been defined for us into which we can supply the various pieces of code. So this helps us define our function. Now, in the simplest kind of function definition, all we need to do is supply the name of the function here, where it says untitled. So I'm going to call this myfunc. And you can see here that it's suggested that you supply an input argument. So I'm going to supply x, and I'm going to list an output argument as y. At the moment there are comments which suggest that we should be putting some kind of definition of what this function is going to do. So let's make a new kind of function which will square any number x which is given to it and then adds 1 to it. So I'm going to do that here. So if I indent a little bit so that we make the code a little clearer, and we indent a little bit here, we're going to define y equals x to the power of 2 plus 1. So this is a new kind of square function where I add 1 to the answer. And if I now save this function by using Control or Command S, you will see that it is suggested to us that the function name should be the same as the function name that I just defined at the top of the function, which is what we should be doing. So I will save that. And I've now defined my first function, which is highlighted on the left in the current folder window. I can now call this function to see what it does. So I go to the command window and I type myfunc and I hit open bracket, and you can see that it's already learnt within MATLAB that it's expecting some value x. So let's enter a value of x. I'll enter the value 2, and you can see that it's, as expected, it's given the correct value 5. So you can see how the function has worked. What I've done in the function definition is the input argument is taken when I call the function, so this number 2 at the bottom has been passed into the local variable x. X is then used to define y, this is a variable which has been defined to have the same name as the so-called return argument. So whatever is defined as y, wherever it may be defined in this function, will be the value that is returned as the output to the function. So if you think of this as a black box, I've put 2 into the function, and this enters into the function locally as the value x, and then the value y is output. So you can see that if I look on the right hand side, the values of x and y have not been defined in the global workspace environment, in the so-called global scope. That variable x and that variable y have been defined within the function, and for the purpose of doing that one calculation, this myfunc2 at the bottom here, but have then been deleted. So this means I can define another function which also uses a variable name x, and those two variable definitions will not conflict with each other. This is a very important concept in programming. So let's run that function again with a different input. Let's give it the value 3, which works fine. Let's give it the value 1.1, and that works fine. And sometimes this function will work fine with other forms of input. Let's give it an array, 1, 2, 3. Does that work? Yes, it does. So you can see that with a fairly simple function definition, I can obtain a function that has quite sophisticated behavior. Now sometimes when I define a function, the definition that I give for the return value will not be tolerant of different forms of input. So sometimes I will need to have different forms of the function to cope with the fact that I have different forms of the input. And it's up to the user, when you have these user-defined functions, to decide for themselves how they want their function to operate and what they want it to do. So that's the basics of a function. Is it possible to define a different sort of function that has no input argument? Well, let's try modifying our first function, and I'm going to delete the input argument, and I'm going to make this function always return the value 4. So I'm going to save that. I'm going to use Command or Control 0 to go back to the command window, and I'm going to rerun the function. I'm going to rerun it as myfunc. Yes, and it gives the value 4. Does it matter if I have brackets on the end? No. Does it matter if I put an input value in? Yes. So you can see that the number of arguments supplied to the function has to match the number which have been defined in the function definition. There are ways around that to allow variable numbers of arguments, but in this simple demonstration we won't show them. Now, is it possible to do multiple return values? Let's see if we can return two values, y and z, for a single value of x. So this new function, I want to have y is equal to x squared and z is equal to x cubed. What happens when I run this? Well, let's type myfunc of 2. You can see that it's returning the value y, but not the value z. That does not mean that the value z has not been generated. Actually, it has. But in order to obtain that value, we actually need in MATLAB to give MATLAB a place to put the value. When we just simply call myfunc3, you will see that by default the output of that function is being sent into the ANS variable, and that's why it is then printed on the screen and the value ANS has been defined. If I wish to obtain the second value from my function, I need to give MATLAB somewhere to put it. So rather than having a single default place, so you might say like a post address to put the result of the function, I'm going to give two places to put the post address. So I'm going to define two values. I'm going to define them as a and b to be the result of myfunc when acting on the argument 3. So if I now hit return, you will see now that two values have been returned and two more variables have been defined. So a and b have been defined and are now taking respectively the values y and z which have been defined within the function. And again, this highlights the basics of functions, which is that the value y that is being generated locally within the function, when I call the function and ask for that y value to be generated, it has been given to this result a, where I've asked that function return value to be returned to. And in the case here, where I have two return values, I can post those two values to two different places and into two different variables. And when I do that, of course, you can see that a and b have both been defined and are available now in the global workspace, where the local variables y and z, and of course the input argument x, are not available within the global workspace. So that's the basics of doing functions. In later videos we will show a little bit more about how those functions might be used in multiple forms.